Hello AAT, we are doing rational and radical functions in this new unit, and this is 4.1, looking at rational expressions. A rational expression is a quotient of two polynomials. So remember, quotient just means division. So basically we're looking at fractions or a division symbol where we'll see an x in the numerator and the denominator. That's a rational expression. This is all reviewed from Algebra 1. It's not even Algebra 2. So all these exponent properties, like anything to the 0 power is 1, you should know these already. If you're multiplying two things with the same base, you add their exponents. You know about negative exponents, mean to reciprocate it, flip it, or bring it to the bottom. If you have division, you subtract the exponents. A power to a power, you multiply the exponents. And don't forget, if you have a fractional exponent, it is going to be the power over the root. So I'll just review these problems. I think you'll find super easy. So remember, when you have the same base, you're going to subtract the exponents. Make sure you always bring it to where the larger exponent is. 8 minus 6 is 2, but that x squared is on top. Power to a power, x squared to the cubed. You multiply for a power to a power. Y to the first to the cubed is y to the third. Easy, easy. X to the fifth over, what do you think? Y to the 15th. Can't simplify these because they do not have the same base. A negative exponent means to reciprocate it. That means bring it to the bottom if it's on top, bring it to the top if it's on bottom. So if everything goes to the bottom, that would be 1 over y to the 15th, where this one would come up and be x to the 15th. Here, notice, again, we're subtracting exponents, but there's 9 of them on the bottom and 6 of them on the top. And you can think about it as, you know, writing them all out. There's 6 A's on top and 4, 5, 6, 7, 8, 9 A's on the bottom. So all of these A's divided by all of these A's is 1, and then you just have 3 A's on the bottom. If everything goes to the bottom, you have 1 on top. 1a over a to the third. So we're just subtracting, and where the largest exponent is, make sure that's where that a to the third ends up. Be careful when you have a coefficient. This is not 2 times 3. This is 2 to the third times c to the power to a power multiply. And 2 to the third is 2 times 2 times 2. Write it out if you need to. Is 8c to the 6th. Okay, so keep going. We can only combine things with the same base. These all have the same base, so if we combine the top and the bottom first, 4 plus 6, we add the exponents when we're multiplying. 8 plus 2 is into the 10th on the bottom, and anything over itself is just 1. Here, 4 times 3, make sure you multiply those coefficients together first. A to the 5th times a to the 3rd is a to the 8th. Super easy. Keep going. We're going to simplify each individual fraction here first. This is v to the 4th over v to the 3rd. Excuse me, v to the 4th over 3 to the 4th. And 3 to the 4th is 3 times 3 times 3 times 3 is 81. V to the 2nd is 25. Excuse me, 5 to the 2nd over v to the 2nd is 25 over v to the 2nd. Each thing gets that power. Then if you can cross cancel, you can always do that because this is v to the 4th divided by v to the 2nd. So you have a v squared on top. Make sure it's where the larger one is. And simplify 25 over 81 if you can, but that cannot be simplified. So that's your answer. Here, power to a power we multiply, that's x to the negative 4th. 2 times negative 2. And we bring that to the bottom because it's a negative exponent, means to reciprocate it. And here, if everything's to a negative exponent, we're going to flip the whole thing. They're both to the first, but to the first, of course, is just x over 2. All right, moving along. Now we are simplifying Here we have, some of these are going to start having addition and subtraction. Remember, you can only cancel things connected by multiplication. If you have something connected by addition or subtraction to something else, you've got to try to factor it before you try to cancel. Because canceling is division. It's a number divided by itself is 1, or whatever you get in that case. So here, we're going to simplify. 6 divided by 36 is 1/6. So we've simplified our coefficients. So I got a 6 on the bottom, a 1 on top, but I don't have to write that. I have 2 x's on top and 1 on bottom. That leaves me with 1x on top. Y to the third over y squared is just a single y on top. Very easy. Okay, here, this one, everything's connected by multiplication. So the best thing to do, don't try to do everything at once. Let's just combine that denominator first. Coefficients first. 10 times 9 is 90. D to the negative 4 times d squared. You add the exponents is a d to the negative 2. Okay, I got a negative exponent. Negative exponent means to reciprocate it, bring it up. So now I have 8d times a d squared, because I brought that up, over what's on the bottom, 90. And then a d and a d squared, add the exponents, is 8d cubed over 90. Try to simplify this fraction if you can. And we know they're both even, so we know they're divisible by 2, so that's 4d to the third over 4d to the third over 45. Okay, now we start looking at the ones with factoring. So all the time people try to cancel these 3's. You cannot do that because this 3x is connected to that 9 by subtraction. You cannot cancel things unless they are just connected by multiplication to everything else. So we have to factor these first. Good thing we are really good at factoring. So here this has a GCF. This is 3 times x minus 3. This bottom one has a GCF, x times x minus 3. Now these are connected by multiplication. So since everything here is the same as everything here, x minus 3 divided by x minus 3 is 1, and 1 times 3 over x is, of course, 3 over x. So make sure you factor first. So on this next one, we can factor this trinomial here. I know it's going to be 2x times x. We're going to have to factor the denominator. I can tell that one also is going to be 2x times x. So on the first one, we need two things that multiply to be 3, but the inner and outer terms need to add to be negative x. So remember how we did this? We got 2, 1, and 3, 1. So the first is 2. The last is negative 3. We'll worry about the negative in a minute. When we cross multiply, we get 2 and 3. They need to combine to be a negative x. So 2 minus 3 is negative x, which would mean this needs to be a negative, which is good because we wanted a negative 3 here. So first is 2, last is negative 3. When we cross multiply, they add to be negative x in the middle. So our first should be 2x and x. Our last should be negative 3 and 1. Put that plus in between it. Okay, very similar on the bottom. So our first are 2 and 1. Forgot my x. Your last could be 6 and 1 or 3 and 2. So I'm going to try 3 and 2 because I can tell that looks good. So that's 4 and 3. They need to combine to be a positive x this time. So 4 minus 3 is positive x. So a negative here. So that's is negative 6. So first, last, middle when we combine them. So we got 2 and 1 as our coefficients of the x, and negative 3 and 2. Now it's factored. We could FOIL it back to check. These factors are connected by multiplication, so I can cancel these because 2x minus 3 divided by 2x minus 3 is 1, and I'm left with x plus 1 over x plus 2. Don't cancel those x's. They're connected to something else by addition. Okay, this crazy looking thing, still no different than the ones we did at the beginning. They're just kind of ugly looking. So we could either combine everything first, or we could try to cancel a few things first. Everything is connected by multiplication on top and on bottom. So we can go ahead and divide out and cancel things. So I would see, I got this 27 here, and I know 9, we're going to 27 3 times, so that helps. And I know I could do 3, we're going to 3 1 time, so that's gone. Now I'm a little afraid I'm going to get too confused about my work, so I'm going to write out what I have. I have an x times x to the 1/3 times an x to the 3rd over an x to the 10th and a 2. Okay, so it looks like there's nothing going to be done to that 2. So now I can kind of simplify these. I don't want to deal with a fraction until I have to. So x to the 1st and x to the 3rd is x to the 4th. I'm coming back to that fraction, x to the 1/3, see if maybe everything else will go away. So x to the 4th over x to the 10th, I would subtract and put it where the bigger one is. So 10 minus 4 is a 6 on the bottom, x to the 6th. So I have x to the 1/3 over x to the 6th times 2. Okay, so now what do we want to do? Well, we need to subtract these and bring it where the larger one is, which is in the denominator. So I need to do 6 minus 1/3. 6 minus 1/3 is not that scary. We need a common denominator of 3. So if I multiply the bottom by 3, I multiply the top by 3. So that's 18/3 minus 1/3, which would be 17/3. Weird, but that's what our exponent is going to be in that denominator. We're bringing this down, subtracting, because we're dividing, subtracting those exponents. We have a 2 still on the bottom, and when everything leaves from the top, we have a 1. Okay, make sure you go back. That one's kind of tricky. Go back and look at it. Okay, this one, lots of addition and subtraction. So you've got to factor everything first, and then cancel, divide out what you can. So I'm going to ask you to pause right here and give that a try, and then we'll check. Okay, and we're back. So this is what I got when I factored everything. Notice I just made it one big line because these are multiplied, so everything can just kind of go together there on one long division line. So we factored this first one. It had a GCF of x, and then it was difference of two perfect squares, x minus 3x plus 3. This one, two things that multiply to be -8 and add to be 7, x plus 8, x minus 1. This one, x plus 8, x plus 3, and then this one, x minus 3, x minus 1. And then I can cancel. X minus 1 divided by x minus 1 is 1. X plus 3 divided by x plus 3 is 1. X minus 3 over x minus 3 is 1. X plus 8 divided by x plus 8 is 1. Oh, I love it when everything cancels. All we're left with is just a little x. All right, moving on. Okay, number G, letter G, is what we call a complex fraction because it's got this fraction in it, here. So I'm going to start with writing down what I have in the first fraction, x minus 6 times x plus 2. And this big fraction line, remember fractions are just division. So division for fractions is to keep the first, 2x minus 1 over x minus 6, change to multiplication, and flip the bottom, x plus 2 over x minus 2. Oh, that's nice. Now we don't cancel until we factored everything, but everything already is in factors. So x minus 6 divided by x minus 6 is 1. X plus 2 divided by x plus 2 is 1. And I'm left with 2x minus 1 over x plus 2. All right. H is another factoring problem. Be careful. There are coefficients in front of the x squared term, so you're going to have to do either your cross multiplying trick or slide and divide if you prefer that, which isn't my favorite, but okay, anyway. But make sure, since this is division, you're going to have to change to multiplication and flip this. Okay, so keep, change, flip, factor everything, see what cancels, and pause here to get it. All right. So here is what I did when I factored. I got 2x minus 3 over 5x plus 1 times flipping and factoring this second group of fraction, or polynomials in a fraction, rationals. So now we cancel, and everything cancels. The 2x minus 3's cancel, the 5x plus 1's cancel, and the 3x minus 2 cancels. So what do we get when everything cancels? Well, remember, canceling is division. 5x plus 1 divided by 5x plus 1 is 1. So we have a 1 times a 1 and another 1, which are all just going to be 1 when everything cancels away. It's not a 0. Okay, almost to the bottom of the page. I. Simplifying here, we got power to a power. So a squared to the 6 is a to the 12. If you think you know how to do this, pause it, do it, and then come back and check. B to the first to the 6 is b to the 6. C to the 48th. A to the negative 9. A negative exponent would come to the bottom, a to the 9th, times b to the 4th, times that really weird little x out there to the side. Okay, now we combine any like terms we have. We have a to the 12th over a to the 9. Subtract. That's a to the 3rd, and it goes to the top because that's where the bigger exponent is. So a to the 3rd, we got a b to the 6th and b to the 4th, which is a b to the 10th, add c to the 48th, and an x. Okay, so try the last one, do your power to a power. I would first flip everything with that negative. Okay, let's kind of walk through how I did this one. First of all, if you have all these negatives going on, negative exponents, you can do two things. You can do the power to the power first, or I think it's a good idea to flip everything first and get rid of that big negative on the outside because it gets very confusing. So inside, I flipped everything. The 4 came to the top, the x to the negative 4, b to the negative first. We flipped everything first. But these exponents have not changed to positive because that was what happened with this negative. So we still have these two negatives, the negative 4 and the negative 1. So on my next step, I'm going to bring those up. So the 4 was already up, and then I bring my x to the negative 4 up, and it becomes x to the 4th. I bring my b to the negative 1 up, and it becomes just a b to the 1st, or b. And these are all to the 3rd. So do one step at a time, and don't forget to bring down that 2x to the 5th. Now a power to a power, 4 to the 3rd. Write that out. Don't try to do it as you go. X to the 4th to the 3rd is 12th. B to the 3rd is b to the 3rd. And then we have this thing. And so the last thing, you need to know that b to the 4th is 64. And then it's times another 2. So 64 times 2 is 128. We got an x to the 12th and x to the 5th is x to the 17th. And b to the 3rd. There is your answer. Okay, we're going to stop there and come back for the second video to finish this section.